Alrighty, so today we are going to be continuing talking about how we can use for loops to iterate through a container, specifically strings. Then we'll talk about nested loops, specifically nested for loops. This can be kind of tricky to understand, so hopefully we'll get some more clarification on those. And finally, we will talk about writing our own function. We've actually been using functions pretty much since the beginning of class with our POW and square root and absolute value, but we're going to actually learn how to write those ourselves. So starting off, we are going to be looking at iterating through strings. So we took a look at this yesterday. So basically, the general idea is you have a for loop, and this for loop is going to allow you to access every single element in your container. For this example, we have a string. We have the string 2022, and this for loop right here is going to allow us to access every single character in our string on its own. And this is a process called iteration. It's super important. You'll be seeing it a lot, especially when you get to vectors. So how it works is you have an unsigned int I, and it's always going to be, well, not always, but generally it should start at 0, because if you remember our indices for strings and everything else in programming, those guys start at 0. So we're going to want our I variable to also start at 0. Then it's always going to be I is less than whatever container you have dot size. And then finally, I++. This is going to be something, this exact like formula right here, you'll see it all the time. So if you're wondering what you should memorize or like get down, it's going to be this line right here. So almost every single time that you're going to quote unquote iterate through something, it's going to be this. Then we are allowed to say the container dot at the I variable, because I is going to have the value of every single one of our indices in our particular string. And then that will allow us to look at every single one of those. I talked about it yesterday, just wanted to quickly review it before we actually do the exercise with them. Before we do the exercise, any questions on iteration? No, we talked about it yesterday. I don't want to go too much detail. Okay, perfect. All right, so what we are going to do is we are going to use what we learned about iteration to do a programming problem. And this problem is actually from this site, rosalind.info. It is actually for Python, but we can take the ideas and apply them to C++. So the general idea with this program is you are going to be given a string of DNA like this. And then what your job is, you're going to determine which of the strings are valid DNA symbols. So let's say you had like some gibberish in here. We want to ignore this. Okay. And then your next job is you're going to determine how many of these symbols are either G or C. And then the final task is to output what % of the valid DNA is G or C content. And this has something to do with biology. I don't know everything about it, but it does have real world applications. That's kind of cool. So I'm going to screenshot this so I can move it to the desktop, and then we will get started on that. Alrighty. Okay, so now I'm going to open up a text editor, and I will get the basic stuff down for you, and then you can help me with the actual iteration part. All right, so now what our first task is to take input for a string of characters. So you know that to do that, we're going to just create a string variable, and I will just call it DNA. And then I'm going to just use a cn statement to take input for that DNA string. All right, so now we should have in this string DNA whatever the user decided to enter on the console. So now your job is to help me out with how can we determine how many of these, we're just asking for a number, how many are valid DNA symbols. So which of them are either A, T, C, or G. So how do you think we could do that? And you are absolutely right. I should make this a CPP file. So I'll call it DNA.cpp, just nice and short. All right, there we go. We have a CPP file. So now how do you think I can determine which of these are A, G, C, and T? I'll look at specific letters. Okay. Do you perhaps remember what command that is? Okay. What we're actually looking for here is we're going to try using the iteration method. There are definitely other ways to do this, but we're trying to focus on iteration in this particular program. So I'm going to just have a random string of characters here. All right, so this got input into DNA. Let's pretend that that happened. Now, what our job here is we want to look at every single one of those characters and determine if it is either A or C or G or T. So we're going to look at this. We're going to say, is it A, G, C, or T? And then if so, we're going to add 1 to a counter variable. That is not the correct syntax, but you get what I mean. We're going to add 1 to a counter variable. Then we'll see C, and we'll add another 1 to our counter variable. Then we'll see a T, and we'll add another 1 to our counter variable. G, A, O. This is not a valid DNA symbol. We're not going to add 1. E, we're not going to add 1, and then 1, we're not going to add 1. So you see how we kind of have to look at every single character in the string for this? So what can we do to look through every single character in our DNA string that we have? What would we want to do for that? All right, well, to go through every single character in a container, we use the process of iteration. And for iteration, you use a for loop. So we're going to start working on that. So for our for loop, we're going to start with the keyword for, and then we are going to do unsigned I. Wait, that's not spelled correctly, is going to start at 0 because our very first index in our string will always be 0. And then we're going to continue looping while I is less than our string, so DNA dot size. And then finally, we do I++ to increment I. And just about every single time you're asked to do iteration, this will be your format for that. All right, so now using this for loop, we can take advantage of how I is going to represent every single index in our string. So on our first iteration, I will be 0. The second one, I will be 1. And the third iteration, I will be 2. And then we will reach our limit for our for loop and we'll exit. And these, that was if we have a DNA string that was of length 3, of course. So what we're going to want to do here is now we have I, and we can use I as our index to access the characters. So now our job was to determine if our DNA dot at I. So I is going to represent our index here. And then we want to figure out, okay, is this character that we have access to here equal to a capital letter A? And then we can check, or is DNA I equal to a capital C? That's one of them. Yeah, it is. Okay. And then we do or is equal to, we need a G. And note that these are characters because dot at will return a character. We have to compare characters with characters. And finally, is equal to T, capitalized. All right, so now we have an if statement, which is going to determine if our character at I is one of these valid DNA symbols. So that accomplishes our goal here. And now that we have, so if we enter this if statement, we know that our DNA.I is going to be a valid character. And when it's a valid character, what do we want to do? Well, our final output of the program, we need to know what percent of the valid DNA characters are G and C. So the first thing we're going to need to know is what of these are actually valid. So we need a counter. So we're going to create a new variable called int, and we'll call it DNA count. There we go. And we are going to initialize this to 0. So the compiler doesn't allocate something else because we want our counters to start at 0. And then we know once we enter this if statement that we have here, we are going to increment our counter because we found a valid symbol. So we'll say D++. We can use the plus operator, or we can increment it by 1, whatever you feel comfortable with, but this works as well. Now, every time we enter here, we are going to increment DNA count. And if we don't enter, we are not. And using that few amount of statements, we are able to go through every single character in a string of any length and check this. So let's go ahead and run it and see if that worked. And to see if it worked, I'm going to output our counter variable and make sure it is getting updated. All right. So we have no errors, that's good. E.out, and I'm going to give it just some gibberish, and I'll make sure to include a few of the valid ones in here. All right, so we have A, C, and G, so we should expect a 3. And we get a 3. So that means our loop worked. It looked at every single one of these characters, determined if it's a capital A, or a capital C, or a capital G, or a capital T. If so, it incremented the count, and if not, it did nothing. So that is perfect. Why is there a percent after the 3? Yeah, so what happened here is when I outputted the DNA count, if I ran this again, just some gibberish. There we go. It gave me a percent at the end. And the reason is I didn't stick an end line at the end of my cout statement. So what endl does is it moves you down to the next line. And since I didn't do that, it put my command line prompt, which as you notice is a percent right here. It put it up here after the end of my program. So that's just something that's happening with the terminal. It's not a part of the program. And this can happen if you don't have an end line at the end of your line, which is why we generally put them there. Does that make sense? All right, perfect. So our next job is we're going to do something very, very similar to this, but instead of counting all the valid DNA symbols, we are going to just count G and C. All right, so how do you think I want to do that? So I think what we're going to want to do is we're going to need to look at every single character in our string again. And instead of counting all the valid DNA characters, we're going to count only G and C. So we're going to make a new counter variable for this. So I'll say int gc count. And we're going to set it to 0. So our count does not get thrown off. And next, we're going to just do our standard iteration loop. So for that, it is for unsigned. I is going to start at 0. I is going to be less than our string dot size. And finally, it is I++, just about every single time. Rare cases where that is not the case, but very rare. Okay, so now what we're going to want to do is we're going to do similar logic to up here. We're going to say if DNA at our index I, if that is equal to either G or if DNA I is equal to C. And now it's going to look at every single character in our string that we fed it in the input, and it's going to determine, is it G or is it C? Or every single character in our string, I'm sorry, every single character in our string, and it's going to determine if that character is either G or is it C. And if so, we enter this if statement, and then we increase our GC count. Does that make sense with the whole iteration loop, why it works like this and how it works? Okay, great. Basically, we're just making use of I because I is changing and it actually happens to be the exact indices that we want to look at when we format it in this way. All right, so now we have our GC count is going to have a variable, and then we have this total DNA count is going to be in a variable. And now our final job is to output back what percent of the DNA is either G or C. So what do you think we could do for that?
We'd have to use this the variable first, right?
A new variable?
No, or could we just use that one already?
Potentially. So we could
like-
just put it directly in a cout statement and not store it. All right, James, I will take that. So, uh-oh, that is not what I wanted to take. All right, so this, let's see what this prints. And I'm going to steal my string that I know is going to be 56%. Alrighty, and we're going to recompile. Uh-oh. There we go. And running it with the string, it is telling us 34. Not quite. What that actually gave us was how many symbols in this string are either G or C. So we went through this entire string and we found out which of them are a C, which of them are a G, and that's where that number is coming from. So instead, we want to know what percent of all of this, these are all valid, by the way. So I can say what percent of all of this is just G and C. This is a little bit of math stuff. I'm not actually very good at calculating percents, but I'm pretty positive that we can find the percent by taking the smaller number, dividing it by the bigger number, and then multiplying by 100. If I am in any way correct here, I did it last night. So hopefully that is what I did. So the 5%, I'm pretty positive we take the small number, divide it by the big number, multiply by 100. So our big number is DNA count. This is what we want to find. We want to find the GC count of DNA count. So we're going to do DNA count. And we're going to divide it by GC count. And then we're going to multiply that by 100. I'm pretty positive I have the answer if this for whatever reason doesn't work. And then we will just call this and we'll assign it there. And now we'll output back to the user. And end the line. So let's see how we do. All right, does anyone see any problems with this or do we think it's all good? Now we can run it and find out. I did not save. That is the first problem here. %. Now, why on earth would that be? I'm pretty sure the 100 is just to, it's the equation to calculate percent. I'm very bad at explaining math, so I'm pretty positive you take the, so if we did it on a calculator, let's just say that we have 64 symbols. Wait, we want to go the other way. We want to do little number divided by big number. Okay, so we said that we had 34 GCs, and then we divide that by, we'll just say that the total DNA count is, I'm just making a rough guess, 64. And then that's going to give us a small decimal number. I don't think you can see the calculator. It gave me 0.53125. And that is not a percent, but to convert it into a percent, we have to multiply it by 100. And now we get 53. So obviously my guess of how many were were valid DNA was off. However, to get the percent, we do have to multiply that small decimal by 100. Because otherwise it's going to give us a decimal answer. And when we want a percent, we like a whole number. Does that make sense? That's how we get the decimal into the equivalent percent. Okay, perfect. So we're just taking a tiny decimal and then we want to convert it into its equivalent percent. And we do that by multiplying by 100. All right, so now that I have the code actually in the correct order, let's see what we get. Not that. All right, the total GC content is 0%. Well, why on earth would that be? Well, we have, actually, do you guys know why on my calculator it works, but here it didn't?
I'm trying to figure that out.
All right, take your time. I'll give you like a minute.
I'm not sure, but I feel like something with the count, or I don't know.
You're actually correct. It is something with the count.
Oh, really?
Yeah. So the thing that's happening here is, again, I'm just making up numbers because I do not know how long that string is. So I'm going to just assume that GC count is 34 and DNA count, I'm going to just say 64 again. And we are dividing 34 by 64. And take a look at this. We have 0 up here, and then we have some stuff. But this is what we care about because we have an int and an int. We ended up doing integer division by accident. So this resulted in 0. And then 0 times 100 is also going to be 0. So that's what's going to put in percent.
Okay, yeah, I see.
Tricky one. So yes, that is what happened. We accidentally did integer division. And to fix that, we can just change our ints to doubles. Usually with counts, we make them ints, but because we are doing this specific calculation, they do have to be doubles. All right, so now we have our doubles, and I'm going to actually save the program. Remember to do that this time. Okay. And now we give it our string. There it is. The total GC content is 56.6667. You could do your IO manip to make that a little prettier, but this is exactly what we were intending to do. The main focus was the iteration portion. So hopefully at least that part made sense. Any questions on iteration before we go into nested loops? Nope. Okay, cool. And again, this program is not a creation of my own. This is from this website. It technically has a bunch of coding challenges. They are in Python, but I adapted one for C++. Alrighty, so now that we have talked about our iteration, we are going to look at nested loops. So nested loops can be really, really tricky. In fact, they were the most confusing part of this class for me. So I want to make sure that you at least get a general understanding of them. I know they're so fun. We love nested loops. So a nested loop is just any loop that can appear within another loop. It could be 2 for loops. It could be a while loop with a for loop in it. It could be a do while loop with many for loops inside of it. You can have it more confusing, but you can do it. You can do it. And there are some times where you definitely need to do it. So a nested loop is generally made up of an inner and an outer loop. We call this one right here the outer loop. And then we have one on the inside, which is called the inner loop. That's this one right here. There we go. This is the inner loop. And technically you can nest as many loops inside of each other as you want. You can nest 50 if you really wanted to, but generally you will have one inner and one outer. And we are going to look at how this loop is actually flowing in the code. So we are our compiler and we are going down our program and we see a for loop. All right, so now we know that this outer for loop right here is going to iterate some number of times, in this specific case, 2. So we know that the whole outer for loop thing is going to iterate 2 times. But we are going to check is j, which is 0, less than 2. It is. So then we're going to hit this cout statement here. And we're going to print some stuff to the console, right? We're going to say we're in the outer loop. Then we're going consecutively down in the lines. So we're going to hit this inner for loop here. And we are going to execute that inner for loop now. So now we say, is I, which is 0, less than 3? It is. And since it is, we are going to say, okay, now we're going to do another cout statement here. And that is going to be coming from the inner loop. It's not working. There we go. So we're going to go here. And now it's still an inner for loop. This is still a for loop. So when we hit this curly brace, we don't jump down here. We treat this for loop completely independently from the outer for loop. It has no idea the outer for loop is even existing. So we're going to treat it just like a regular for loop. We are going to go back up to the top and we're going to increment I. And now I is going to increment by 1 and we'll do the stuff in the inner loop again. So since I is still less than 3, we're going to output this thing right here. And then we're going to go up again. And we're going to keep looping the inner loop until our condition is false. And that is when we exit and come back up to the top and do the outer loop. So we have a program which shows this exact thing. And hopefully that will help you see once we have some output. That's not my scribbles. Get that pulled up. There it is. Okay, so here is that exact program that I just showed you guys. And we're going to take a look at what it outputs. So okay, there it is. So what's happening here is we have our outer loop. We went down into the loop. And then since this was valid, we printed the first outer loop statement. Then the next consecutive thing in the code was the inner for loop. And we went ahead and we completed this, basically ignoring that this even exists. When you ignore that that exists, it's not so bad, right? It's just a regular for loop. And we know that the stuff in the body is going to print out 3 times. And that's exactly what happens. We have inner loop printing out 3 times. Well, now we've exited our inner for loop. And since we have exited it, that means that we are going to hit this curly brace. And since that curly brace is attached to a for loop, we are going to go all the way back up to the top and we're going to reassess for the original for loop. And since J is still J is now 1, so we're going to say is 1 less than 2, it is. And since it is, we are reprinting our outer loop and that is happening right here. And finally, we have done our cout statement and the next thing in line is our inner for loop. And now since we're at the inner for loop, we get to ignore the whole existence of the outer for loop and we get to just focus on this inner for loop. And now when we see that, it's not so bad. We're going to print inner loop 3 times. And the reason why I is now reinitialized back to 0 and we didn't start off at 3, which it was left off from the previous looping, we have this I is assigned with 0 again. So it's resetting I back to normal. And then we do the inner loop 3 times. And then when we exit the inner loop, we're going to go all the way back up to the top of our program, of our for loop. And then we're going to check, is our J variable, which was holding the value of 1, we're going to increment that by 1. And now it's 2. We're going to say it's 2 less than 2. And this is false. So then, since it's false, we jump from this brace to this brace, just like a regular for loop. We can pretend that this inner for loop is just random code. It really doesn't matter what it is. Whenever the statement is false, you don't do anything that's inside the loop. So we ignore that the inner for loop exists this time. And that's kind of the flow of these. It's a little bit confusing at first how they're all connected together, but in a lot of cases, they're pretty independent from each other. You can look at the inner for loop and the outer for loop pretty separately and just note, okay, we have some code here and whatever this code is going to loop the amount of time specified by the outer for loop. And then this code right here is going to just be looping its regular amount of times for the inner for loop. Hopefully that flow of the code makes some sense. Okay, perfect. I'm glad because that took me forever to figure out my first year, what was happening in these for loops. Oh my God, it took me at least 5 weeks or something it's still confusing, but you just can pretty much think of these independently. You have a section of code in the middle, which is going to loop the amount of times that the outside loop specifies. And if it's an inner loop right here, we're going to just do the regular stuff that's happening in it and completely ignore the existence of the outer loop. There are some times where you have like a mixture of the variables, like you might say that I is starting at J for whatever reason, probably not valid code, but you might mix them a little bit sometimes, but generally, if the variables are independent from one another, so if one thing is false, then it goes to the other one. Exactly. So if our inner loop right here ends up being false, for whatever reason, see, we did 3 loop 8 in the code happens to be this curly brace. And since we hit a curly brace that's attached to a loop curly brace up here, we are going to go all the way back up to the top and reassess for the original loop. So that's what's happening there. And we have a few more examples of this. This one I think was helpful because it's not like a bunch of numbers. I do have one that's a bunch of numbers. So we're going to take a look at that one. Next exercise that we have here, I have another loop for you guys. And with this one, I have a few questions. The first question is, how many times does the inner loop iterate?
6 times.
You were actually correct the first time. My brain was jumbled. I did not sleep at all. Okay.
You're good. You're good.
Okay, let me re-explain what I just explained on accident, completely wrong. Okay, so how we calculate this is the outer loop is going to iterate the number of times that is listed right here. That's how many times the outer loop is going to iterate. Right there. Right. We have it iterating 3 times. The inner loop is going to iterate the number of times that it iterates on its own. So that would be twice, and then multiplied by the number of times that the outer loop iterates, which is 3. So the inner loop is going to iterate 6 times. And now that makes a lot more sense with our past program. So we previously said we had a program and our outer loop was iterating 2 times. Well, look how many outer loop statements that we have. We have 1, 2. Okay, and now we're going to assess how many times do their inner loop statements iterate. Well, to do that, what we do is we look at the inner loop independently from the outer loop, and we say, how many times does that iterate if this all doesn't exist for a second? Well, that iterates 3 times all on its own. But we have this outer loop, and what the outer loop essentially does is it repeats what happens in the inner loop by the number of times that it is programmed to repeat. And it's programmed to repeat 2 times. What we do is we say 3 times 2 is going to be 6. And when we look at this, oh my gosh, this makes so much more sense. I'm so sorry. We have 6 inner loop statements here. So that was what's happening. The inner loop repeats it independently multiplied by the outer loop. And that's how many inner loops you're going to end up with. Outer loop, just you can forget that the inner loop is even there. And you just look at it and say, oh, it's 2. Okay, there we go. That makes so much more sense. That's great. Okay, so now what we're going to do is we're going to look at this loop that I have here, and we're going to figure out the output. So it's a little bit more confusing because we have numbers instead of just our statements, but we are going to take a look. So now we're going to say J is 0. We're going to just keep track of these variables because they are important to keep track of. And now we're going to determine, is J less than 3? It is. And since it is, we're going to enter our for loop. And the first thing that we come across is another for loop. And in this for loop, we establish a new variable. So we're going to make a new row for that. And I is going to start at 0. And then we're going to test, is I less than 2? It is. And since it is, we execute the loop body. And what the loop body says to do is it says to output the value of J and the value of I. Well, we can look at our variables over here and we see that J is 0 and I is 0. That's our output. All right. And now since it's a for loop, we get to basically ignore that this is happening for a second. We're going to just loop completely regularly. So we're going to go back up to the top and we are going to increment for I. So now I has the value of 1. Then we do our test. Is I still less than 2? It is. And since it is, we are going to output J and then we're going to output I. So on our table, we can see that J is 0 and I is 1. Okay, so now we are looping again. We come back up to the top and we're going to increment for I. I is now 2. Well, James, you're absolutely correct. 2 is not less than 2. So we are not going to do anything in our cout statement because this is false now. And when it's false, we do is we jump from here to here. And the next statement in our program is this curly brace. Well, that curly brace that we have right here is connected to this one, which is a for loop. So what we do is we come all the way back up to the top. And then what we do is we are going to do the outer for loop now. And the next step in the outer for loop is to increment for j. So now j is going to have the value of 1. All right, and that's all the outer for loop says to do, is just increment the value of j. All right, so now we head back down. So the inner for loop is our next statement that we have to do. I is reset back to 0. We check, is 0 less than 2? It is, so we're going to do this statement. And now we see that our output for we have j is 1 and I is 0. Perfect. And then we go back up to the top. Again, yes, exactly, rinses and repeats. And then we go back up to the top. We are going to increment for I is now 1. We check, this is true. So we are going to do another output statement. We see that j is still 1 and now I is 1. And then our next statement that we do is we go all the way back up to the top again. And now I is going to have the value of 2 because we incremented for I. And then we're going to test, is 2 less than 2? It is false. So we're going to jump from here to the next statement in our program, which happens to be a curly brace, which is connected to this for loop here. So we're going to go all the way up to the top again. Very exciting stuff, I know. Luckily, we are almost done. So now we are going to increment for j. So j is going to increase by 1. So now we are at j is 2. We check, is j, which is 2, less than 3? It is, which means we go back in, and our next statement is our inner for loop. We execute for our inner for loop. I is now reset back to 0. And now we are going to output our values. So I we said is 0, j we said is 2, and we come all the way back up to the top. I is going to be 1. And then we come back into the loop again. We are going to do our cout statement, and our cout statement instructs us to print the value of j, then I. This is 2, then 1. And then finally, we're going to come back up to the top. We're going to increment I, and now it's going to say is 2 less than 2? It is not. So we come all the way back up to the top for the very last time. And we say, okay, we have our j value, which is still 2. We're going to increment it by 1. It's going to be 3 now. And we're going to test, is 3 less than 3? This fails. So now we do exactly as we would for a regular for loop. If we know that the conditional statement is false, we don't care anything about what's in here. We know it's 100% of the time going to just skip and move on with the program. So that should be our final output. Program is written. I'm guessing you could make that an infinite loop with the command. Yes, this would be, a lot of loops are pretty easy to make an infinite loop if you are not careful. This one was pretty dense, but I wanted to really show you guys what was happening, where everything was moving. And let's see, did we get the answer correct? We did. I have 2 slides here and they look absolutely identical. So this was the answer slide, which means that what we did was correct. Any questions on what we just did? Because I know it was a lot, but hopefully that clears some stuff up. Oh, good. I'm glad it was fun. If you like these, that is fantastic because they are the hardest thing to learn.
Yeah, that was pretty clear. It made like sense how you did it.
Okay, great. I'm so glad because these are very confusing. All right, so now we have a programming exercise using nested loops. Our output that we want to create is this little rectangle here, and we are going to do it using a total of 1 cout statement, which is going to have characters in it, and 1 cout statement, which is going to have a end line in it. So you can only have 2 cout statements in this entire program. That is the specifications. and we have to use a nested loop. All right, so that was outputting shapes using nested for loops. I do have another programming activity for you guys, but this is a very long one. So if you do want to do this, go for it. If you don't, I totally understand. We're not going to do it today because it's just so long, but it's kind of interesting. What it is get it running up here. Password acceptor, ants. Basically how it works is you're going to use for loops in iteration to, you know how when you have a website, they want a password that has like 8 characters in length, or it has certain special characters or numbers or capital letters. You're going to basically replicate that. You're going to have the user enter a password. Wait, there we go. And you're going to assess for these characteristics. That's the 8 characters long, contain 1 number, contain a capital letter, and contains at least 1 special character. We can do this on Tuesday if you feel like it, or you can do it on your own. There's a bunch of instructions to on how to do it. Hello, and then when you get a correct one, it just stops doing its stuff. So there's instructions on how to do that. I'm happy to work with you on this program on your own if you'd like, or completely forget it exists. All right, so we can do that another time because it's very long. But we are going to talk about functions because this is something that Steve has introduced this week. Very exciting stuff. Functions are actually really fun, but basically I want to remind you guys that you have been using functions. I'm pretty sure since week 2. I'm pretty sure you guys learned about CMath in week 2, if I remember correctly. And CMath is a library which contains a whole bunch of functions. You have POW, you have FADs, you have square roots, you have all those other fancy math ones that I do not understand. But the cool thing is, instead of using these standard libraries that hold functions for us, we can create our own if we'd like. And that is what we are going to talk about doing. And to do that, you have to define a lot of stuff, but we'll break it down what's happening. We have a syntax for it, and the syntax is right here. There's a lot of things to define, but the first thing you have to define is a return type. What a return type is it defines what the function is sending back to the user of the function. So in our previous cases, POW, remember when we raise a 2 to the power of 3, this whole like equation that we have here, this function results in an 8. The return type is basically what our function results in. And with POW, we know that we could do like 2 to the power of 5 raised to the 3rd. So its return type is double. It's saying, okay, whatever I'm going to send back from my function is going to be a double. It sends something back. That's what a return type is. It's what it sends back. And in programming, we have to specify the data types, like for C++ about everything. So we also have to specify, okay, whatever it's going to return is going to be a certain type. The next thing you have to specify is its name. And this can be a name for whatever you want, just like a variable identifier. It has those same rules. They should be pretty descriptive of what your function is going to do. But other than that, basically whatever you want to do, you're going to just call it something. And the name is this thing right here. When we say POW, POW is the name of the function. We're creating our own name. All right, the next things, we have these parentheses. And within our parentheses, we have these things that are called parameters. And parameters are, what are you sending to the function? It specifies what can be sent. And in this particular function, it can be sent an integer for num1, and it can be sent an integer for num2. It's going to take 2 things from the user. It's going to get sent them. And we can look at this here. So in our POW function that we are calling, we can send it 2 things. We send it a base and we send it a power. And those 2 numbers, they're getting sent to some function in some library, but it has to have like a way to intake them, right? And the way that a function intakes those inputs is with these parameters. So you specify how many parameters you want the function to have, how many inputs you want the user to give it, and you also specify the data type. of those inputs because we specify the data types for like everything. And finally, those parameters are separated by a comma, very important. And finally, you have braces. Like usual, when we have some sort of block of code, we usually will enclose it in braces, and that is the same with functions. And then within these braces, you have the function body, and this is where you're going to execute certain things. And that's the syntax for the function declaration. And we're going to look at writing one. And I think it's going to make a lot more sense when we actually do it. All right, so we are going to open a new file that I have here, and it is going to be function declare. And let's take a look at that. So I'm going to walk you guys through defining this function, what you think about, and how to do it. So we are tasked with defining a function named sumnums. In this particular case, we know, okay, this is our function name. We know that, so we can start constructing our function. We don't know the return type yet, but we know it's going to be named sumnums. Oh my goodness. There we go. We know its name. Then the function should take 3 type double parameters. So the parameters are going to go in those parentheses. Now I'm going to pull this to the desktop so you can look at it while I talk about this. Okay, there we go. So now you can look at what I'm talking about. So we're going to write a function, which is going to be of a syntax kind of like this. So we have been given the function name, and we know that that's going to go right here where sum is. So I have written sumnums. Then we also know that our function is going to take 3 double parameters. So I'll start writing those. We're going to have a type double, and then it's going to have some sort of name that we haven't put in yet. Then we're going to have another type double, and one last type double. So the parameters are what you are sending to the function. What can it take input for? It's where those inputs go. All right. And we can actually name them whatever we want. It's like a variable declaration. We could actually name them usernum, usernum2, and usernum3 if we would like to. Because the scope, I think this is something you guys talked about in Zybooks a little bit, and probably with Steve. When you create a variable, its scope is from where it's created down to the next curly brace. So we can use this variable anywhere in here. It's defined there. However, the scope of this variable does not go up here. It's completely separate. So if we would like to, we can actually reuse these same names. Or you can reuse completely different names. These names could be whatever the heck you want them to be. So I will just use this so I can prove to you guys that this works, but you can also name them anything you'd like. All right, so now we have 3 double parameters. And then we know that we are going to have curly braces. And our last instruction is to return the sum. We want to send back from this function the sum of usernum1, usernum2, and usernum3. And to do this, we use what's called a return statement. And the point of the return statement is it tells the function, okay, you're done running. Send this information that you have just gathered back to wherever you were called from. So when we have, for example, our pow function, it has like double pow, it has the parameters that you send it, and then it has the curly braces, and then within the body, it has some statements which are calculating the numbers that you gave it to the power of whatever other number you gave it. And then finally, at the very end of the function, it has a return statement. And this return statement specifies, we have like our function up here doing some stuff. What is getting sent back here? Like the function does all these calculations. And then the return statement says, okay, you did all that stuff, send it all back. It's the output. It sends it all back to where the function was called from. So that's what we're going to do now. So we are going to say return, and then we can return the sum. So we're going to do usernum1, and that's going to be plus usernum2. And plus 3, usernum3. And then it's going to take all this information and send it back to wherever we called the function from. And finally, we have one last step. We have to define a return type. And the return type is just what type of variable do I want to send back? Well, in this case, I'm creating a sum of double numbers. So I probably want to return a double. I want to send back to wherever the function was called a double. And that's it. We have just defined a function which does these tasks. But what actually did we do? Well, we're going to see. I'm going to get my terminal open over here. All right, so now we are going to do G++ function declare .cpp, and we're going to run it. All right, well, it's saying we did nothing. Well, technically, we didn't do any output. We have in our function some calculations happening here. We have some variables happening here. There's no cout statement, so we see no output. In addition, we never told the function, you should run. We have to actually tell it to do that, just like pow. We call it, we say pow, and then we give it some arguments. And that invokes the function run. Your functions are not going to run unless you tell them to. So we need to do that. And we are going to do what's called a function call. And the good news is you've been doing this for a long time. So a function call is just like when we say pow. It's this. This is a function call. But instead of calling pow, a function that someone else defined, you are going to call your own function. So the syntax is your function name, and then followed by whatever you want to send it. So I can send it whatever I want. I'm going to send it 1, usernum 1, usernum 2, and usernum 3. So that is a function call. And now if I want to see that stuff get outputted that I have just written, I would print it just like we would with pow. So we're going to cout some nums, and now let's try running it. Let's see what we get. So there we go. We have written our very own function and we see a 9, just as expected with the inputs that we gave it. So next week we'll talk a little bit more about why our function is outside of main and how that all works, as well as a bit more on functions themselves and vectors. So that should be fun. Thank you so much for watching the video. I'm actually recording this after the SI session is over because we had a very abrupt ending because I accidentally went over time. But thanks again, and I will see you all next week. Bye!